The control room was quiet, almost too quiet. Only the soft hiss of a leaking hydraulic line punctuated the emptiness. A row of warning lights blinked faintly, one amber, one red, each a muted signal that something was off. On the floor beside the console, a stack of inspection logs lay untouched, the most recent stamped weeks earlier than it should have been. The factory floor beyond was a ghost. Machines still, dust settling over conveyor belts and steel girders. It looked like a scene from a post-industrial film. Except this had all happened in real life, in the middle of Detroit, Michigan, at a sprawling manufacturing plant owned by a mid-tier corporate supplier. The facility had been designed for scale. Engineers had drawn up meticulous load charts and protocols, intended to prevent overloading. Workers were trained to read gauges and double-check load paths. In reality, the system had weak points that nobody had traced. Not in the design room, not in the field, and certainly not in reports. The first cracks didn't happen all at once. They began as tiny stress lines in the concrete foundation. A maintenance supervisor noticed one on a routine walkthrough months before the collapse, but the note never made it into the central log. The inspection report cited minor settling, the kind of wording that can be filed away and forgotten, especially when a plant is under pressure to meet production quotas. Above, the steel beams bore the weight of decisions made to save time. Inspections were delayed, sensor calibrations skipped. Each decision on its own seemed minor, almost negligible. Together, they built a chain no one fully appreciated. Operators on the floor trusted the gauges, but gauges are only as good as the maintenance behind them. One overhead crane had a control system that occasionally skipped alarms. Engineers later discovered that the limit switches had never been replaced. For months, operators lifted slightly heavier loads than recommended, each lift adding a small, invisible strain to the structure. The floorboards creaked under extra weight. The vibration of hydraulic presses felt sharper, more insistent. Staff mentioned it in passing, a groan here, a shudder there, but normal production never paused. The plant had become a machine that whispered warnings nobody fully heard. Corporate decisions amplified the hidden risk. Memos obtained during later investigations showed management weighed targets against safety compliance. Requests to schedule independent structural inspections were delayed. Contractors were told to bypass certain checks if they slowed the assembly lines. These weren't wild oversights. They were calculated choices. Each corner cut didn't immediately trigger disaster. It was only later that investigators would piece together just how small the buffer had become. On the day the pivot point arrived, a routine metal load was moved into position above one of the plant's main support beams. That beam had been certified to carry the load, yet as the crane hoisted it, the steel shivered. A subtle, high-pitched vibration ran along the length of the girder, audible only to those standing near the base. One operator glanced at the load chart, double-checked the weight, and shrugged. Everything checked out, and yet the beam had already begun to yield. Microscopic cracks had propagated through months of unnoticed stress. The foundation beneath it bore the imprint of years of deferred repairs. Somewhere beneath the floor, tiny fractures spread like hairlines, weakening the support at a molecular level. No alarm went off. No protocol automatically stopped the lift. The plant was running, production humming as it always did, but the system had silently shifted from safe operation to precarious. Witnesses later described a moment that seemed frozen. The beam holding the load flexed almost imperceptibly, a bend so slight it could be mistaken for thermal expansion or normal sag. Yet in that fraction of a second, the path to failure began. That single support beam, trusted and certified, carried a load it could no longer safely hold. Outside, the lot that had once been a parking area now stood empty, a silent testament to the industrial life that had once pulsed through the plant. Cracks in the concrete foundation traced patterns that no one had noticed, the outline of a collapse yet to come. Rusted machinery lay scattered in storage bays, engines and presses idle, waiting for service that never came. It was in these small, overlooked details that the story of the plant's failure had already begun to write itself. And in that quiet, any engineer would eventually ask the same question. How could a system designed to handle so much fail so completely? The answer wasn't simple. It wasn't a single catastrophic mistake. It was a chain of small decisions, overlooked warnings, and deferred maintenance, all converging on a single point of vulnerability. That point, that one support beam, would become the pivot around which the entire industrial failure turned. By the time anyone recognized the danger, the groundwork for collapse had already been laid. The control room remained still, the hydraulic hiss continuing, an innocent soundtrack to an impending industrial reckoning. Outside, the empty lot waited to record the story that no one fully anticipated. The flexing of the beam was subtle at first, a quiver that traveled through the steel like a pulse. Operators carried on with the routine lift, unaware that the very structure they trusted was quietly surrendering to accumulated stress. The factory had been humming for years, machines synchronized to a rhythm that had become second nature. But beneath the surface, corners cut in inspections, and maintenance were quietly reshaping the mechanical limits. The crane's hoist, rated and certified for the load, had been treated like an infallible tool. Yet it was only as strong as the structure supporting it, and that structure was compromised. The immediate environment offered no dramatic signals. Control panels displayed green lights where red should have flashed. Hydraulic pressures registered within acceptable ranges. Alarms had been silenced or overridden during previous maintenance cycles. To an outside observer, the plant seemed stable, even robust. But engineers later determined that the load-bearing factor of several main support beams had eroded due to corrosion. Microfractures in welds and slight overloading over months formed a ticking clock. The pivot moment came in milliseconds. As the crane lifted the metal load, one of the central beams buckled under the combined stresses. It wasn't a catastrophic snap, but a progressive failure. Operators finally noticed the unusual movement, a soft vibration that didn't match the normal hum of machinery. They attempted to halt the lift, but the automated brakes and limit sensors had been degraded or ignored. The control room's silence became deafening. No button could undo months of deferred inspections and altered protocols. Once the beam bent past its critical point, the load shifted unpredictably. Steel frameworks that had carried daily pressures for years now faced stresses they weren't designed to handle. The hydraulic system groaned under sudden redistribution, pistons vibrating with uneven force. Machines in the immediate vicinity shut down automatically as safety interlocks tried and failed to respond. Workers hit emergency stops, but the inertia of mechanical momentum already had its way. Even the building's concrete foundation began to settle unevenly under localized stresses. Investigators later noted that the failure followed a pattern consistent with both structural and mechanical compromise. The buckling of the beam didn't happen in isolation. Corroded rivets, small deviations from welding specifications, and prior overloads had eroded the redundancy engineered into the system. Safety protocols that might have prevented the incident had all been bypassed or delayed in the interest of maintaining production speed. Early reports cited operator error, but detailed forensic analysis revealed that human action was only the final link in a chain of systemic failure. Within hours, the plant was evacuated and cordoned off. Emergency services confirmed that the building was no longer structurally sound. Sections of the floor were uneven, beams sagging, and machinery either locked in position or jammed. The company released a statement attributing the incident to unexpected equipment stress and promising an internal review. But investigators quickly uncovered internal emails and memos highlighting repeated warnings about deferred maintenance. The disconnect between documented safety procedures and actual operational practice became the focal point for scrutiny. Outside, the empty lot where the factory once operated began to tell its own story. Cracks in the concrete foundation traced the paths of previously overloaded beams. Rusted remnants of equipment hinted at mechanical stress beyond design limits. Forensic engineers mapped deformation patterns and traced them back to key load-bearing elements. Each visible crack became a marker of decisions made long before the pivot point. The narrative emerging from the site wasn't one of dramatic catastrophe, but of quiet erosion, of trust in inspections, of adherence to operational protocols, and of assumptions that safety systems were infallible. Analysts noted that every red flag, missed inspections, outdated load calculations, sensor misalignments, was a small fracture in a larger system. The buckled beam was just the point where these fractures converged, a tangible representation of months, even years, of overlooked vulnerabilities. It was a failure that didn't explode but unfolded in deliberate, almost predictable stages. By the end of the first day of investigation, a pattern became clear. The plant's collapse wasn't caused by a single mistake, a rogue operator, or a sudden mechanical defect. It was the cumulative effect of operational compromises, deferred maintenance, and structural neglect. Each factor on its own might have been manageable, but together they created a precarious state, where even routine operations could trigger the critical failure point. Early investigators began documenting every instance where protocol had been bypassed, every note in a log ignored, every calibration delayed. The goal was to understand not just what failed, but why the system allowed failure to propagate unnoticed. Even as crews began clearing the site, photographs captured twisted beams, bent pistons, and fractured supports. Visual evidence of a mechanical and structural story that unfolded quietly before any dramatic signs appeared. The hydraulic hiss in the control room, once a background detail, became a haunting reminder of what the sensors and gauges had silently recorded, unheeded. On paper, the plant had been certified for every operation it conducted. In reality, those certifications had become meaningless without proper enforcement and oversight. And as the sun set over the empty lot, investigators faced the question that would guide their work for weeks. How could an industrial system, designed and inspected to handle heavy loads, fail so completely under conditions that should have been safe? Engineers returned day after day, mapping every beam, every support, every rivet that had contributed to the failure. The more they measured, the clearer it became that the plant's collapse wasn't the result of a sudden overload. It was the predictable outcome of years of incremental stress. A single support beam, long trusted to carry certified loads, had been silently weakened by corrosion along its joints. Minor deviations in weld integrity and repeated lifts just above nominal capacity. Each overload had been small, imperceptible, but over months, those microstresses compounded. Investigators described it as a system quietly drifting toward instability, a failure waiting for the right trigger. The hydraulic system told a parallel story. Pumps had operated beyond recommended cycles, seals had degraded faster than anticipated, and some pressure relief valves had been manually overridden during peak production. Maintenance records indicated that several sensors and limit switches were overdue for recalibration, yet production pressures often postponed these checks. In a plant where machinery was supposed to communicate strain, load, and misalignment in real time, the silent deterioration had created a blind spot. Operators, following their training and relying on the instrumentation, remained unaware that the system had moved outside safe operating thresholds. One of the more subtle failures emerged in the documentation itself. Inspection logs were inconsistent, often lacking specific measurements or notes on observed deviations. Photographs taken for compliance were blurry or misfiled. Investigators later noted that corporate audits had relied more on paper records than physical verification. Internal memos revealed tension between production targets and safety protocols. The pivot point, the buckling of that main support beam, became a case study in how small errors converge into catastrophic outcomes. That beam didn't fail because it was suddenly overloaded. It failed because repeated minor stresses, ignored alarms, and deferred inspections had eroded its safety margin. As it bent, the load shifted unpredictably to adjacent beams, which themselves had endured similar stresses. A cascading structural compromise followed, each connection, each weld, each rivet stressed beyond design tolerances. The hydraulic presses and cranes nearby jolted under redistributed loads. Safety interlocks engaged too late, and machinery that might have absorbed part of the stress had been partially disabled or miscalibrated. Investigators also highlighted operational gaps. Staff training had emphasized adherence to load charts and alarm protocols, but there was little guidance for situations where equipment subtly deviated from specification. Some operators admitted later that a small vibration, a slight sag, or an irregular sound would have seemed normal. Without a culture of questioning or redundancy checks that compensated for deferred maintenance, human intuition alone was insufficient to prevent failure. The system's fragility was both mechanical and organizational. Outside the plant, the empty lot began to speak a visual language of failure. Concrete foundations were cracked along predictable stress paths. Twisted steel and bent machinery remained as static reminders of what had been designed to move thousands of tons without incident. Forensic engineers traced the deformation patterns to specific points in the structure, confirming that the collapse propagated from the weakened support beam outward. In some places, small fractures in secondary supports had combined with misaligned machinery, amplifying the structural shift. Every observation reinforced the idea that industrial systems are only as strong as the weakest link. The investigation expanded to the corporate level. Emails and memos showed management awareness of deferred maintenance and inspection delays. Independent reviewers emphasized that while formal certifications were in place, they had been applied in a vacuum. The plant, once a symbol of industrial reliability, had become a cautionary tale. Even as engineers cataloged evidence, the human side of the failure remained striking. Every account painted a picture of a workplace where safety and efficiency were perpetually at odds. The tension between documented procedures and real-world practice had quietly reshaped the plant's resilience. By the third day, the narrative was clear but unsettling. Industrial failure rarely manifests as a single, sudden event. It emerges gradually through mechanical wear, deferred maintenance, ignored alarms, and operational compromises. At this plant, every mechanical flaw, every structural weakness, and every procedural gap had aligned in a way that turned a routine load lift into a critical pivot. The buckled beam, once certified and trusted, was now a symbol of systemic vulnerability. As the sun rose over the empty lot, investigators began to grasp the wider implications. What looked like a simple mechanical failure was really a study in the erosion of industrial integrity over time. The deeper investigators dug, the more they realized that the plant's failure was as much organizational as it was mechanical. Structural engineers cataloged the compromised beams, noting corrosion patterns that suggested years of unnoticed exposure to moisture. Welds that had been slightly misaligned during construction were now failing under stress that should have been well within design limits. Concrete foundations bore hairline fractures along high load zones, evidence of both uneven settling and repeated vibration from machinery. Even minor deviations, repeated over time, had compounded into a network of vulnerabilities that no single safety protocol could have prevented once the chain reaction began. Operational records revealed a parallel story. Maintenance schedules had been routinely postponed. Critical sensors had drifted out of calibration, some by as much as 15 to 20%, creating false readings that reassured operators even as components strained beyond their true limits. Internal reports mentioned bypassed alarms and automated systems set to ignore occasional anomalies, intended to prevent unnecessary shutdowns that would interfere with production quotas. On the floor, operators described subtle warning signs: the hum of machinery slightly off pitch, faint vibrations running along steel girders, hydraulic pistons that recoiled differently under load. Each was dismissed at the time as normal wear, yet collectively they were precursors to structural compromise. Investigators also noted the influence of corporate decisions. Emails and internal communications suggested that production pressures often outweighed engineering caution. Requests for independent structural inspections were delayed, replaced by cursory internal checks that failed to capture microfractures or misaligned welds. When engineers recommended replacing certain corroded support beams, the approvals were slow or denied outright, justified by cost and downtime concerns. It wasn't gross negligence, it was the cumulative effect of prioritizing output over resilience. By the time the pivot point, the buckled beam, was reached, these small compromises had stacked like bricks in a tower, each layer adding pressure to the next. The day the beam failed, its initial flexing seemed almost imperceptible. Operators had lifted a load within certified limits, yet the beam's long-term weakening transformed an ordinary lift into a critical stress event. As it bent, the load shifted unpredictably, transmitting forces across adjacent supports and equipment. Machinery responded in unexpected ways. Presses jammed, hydraulic lines vibrated, and safety interlocks attempted to compensate for stresses that exceeded their operational range. The floor itself moved slightly, revealing the hidden fractures in the foundation beneath. It was a textbook example of progressive failure, one small weakness triggering a chain reaction across an interconnected system. Forensic engineers later reconstructed the sequence in detail. Every crack, every twisted girder, every misaligned actuator was mapped to a specific point in the operational history. Sensors and gauges had offered misleading reassurance. Operators had followed standard protocols. Yet the underlying mechanical and structural erosion made the system incapable of absorbing even normal loads without failure. Investigators emphasized that the beam's buckling was a predictable outcome. What appeared sudden to casual observers was, in fact, the climax of a slow, quiet degradation. Outside the plant, the empty lot told its own story. Cracked foundations traced patterns of past stress. Remnants of machinery hinted at uneven load distribution across the factory floor. Rusted beams, bent and twisted, marked where the structural failure had propagated. Every visual cue reinforced the idea that this was not a random or isolated event, but the culmination of systemic erosion. Investigators documented each element meticulously, understanding that the physical evidence mirrored the organizational and operational failures that had allowed the system to drift toward collapse. Even the human element played a role in subtle ways. Operators and maintenance crews recalled near misses, odd sounds, or vibrations that had seemed trivial in real time. Supervisors admitted that production demands often trumped minor protocol violations. Each anecdote underscored a culture in which safety could be deferred without immediate consequence. That culture, investigators concluded, was as much a contributor to the failure as the mechanical degradation itself. Together, these human factors and physical weaknesses aligned in a way that no single intervention could have fully prevented at the last moment. By the time the plant had been secured, the investigation had uncovered a recurring theme. Industrial failures are rarely singular, explosive events. They are often the product of slow, cumulative erosion, mechanical, structural, and organizational. The buckled beam, once certified to carry its load, had become the focal point for months, if not years, of overlooked warning signs. Each misaligned weld, every skipped inspection, every ignored vibration was a thread woven into the fabric of failure. And while engineers could trace each contributing factor in isolation, the system-wide vulnerability revealed itself only in the final, irreversible pivot. The story that emerged was both technical and human. On one level, it was a cautionary tale about material limits, structural redundancy, and hydraulic performance. On another, it was a narrative about operational culture, deferred responsibility, and the subtle ways in which decisions ripple through complex systems. Investigators would later note that even the most advanced safety protocols were ineffective, if not fully implemented and respected. The plant's collapse, they concluded, was a confluence of mechanical erosion, deferred maintenance, and organizational pressures, all converging on a single point of failure. And as they surveyed the empty lot, the twisted beams and the fractured concrete, the question that lingered wasn't just why the beam failed. It was why the system allowed it to drift unchecked for so long.